start over with proteasome, though? Yeah.
Yeah, so there is a particle called proteasome. What is a proteasome? Well, proteasome, it's not really high yield to know the proteasome itself. It's important to know something called the ubiquitin proteasome pathway, the two structures together. So ubiquitin, proteasome, pathway. What is the idea here? The idea that there is a particle called ubiquitin that is swimming around inside of your cytosol. During some signals, it will find out that she has to make the cell smaller. How she's going to make it smaller? It comes here and bind to one area at the cytoskeleton, okay?
Okay.
Then another one here, and another one here, another one there, another one here, another one here.
But, Doc, what is those arm-like structures, Doc? Is that proteasomes?
This one? No, this is the
Yeah.
cytoskeleton, the black one, you mean, yeah?
Cytoskeleton? Okay. Is that like an
Cytoskeleton.
organelle, Doc, in the cell?
We human beings have a skeleton. Why we have a skeleton? It keeps our structure, yes?
Right.
It keeps everything in place, basically. The
Okay.
same as the cell. A cell has something called cytoskeleton. Why it has the cytoskeleton? Again,
Structure of the cell. To maintain the
Absolutely.
structure of the cell.
Yes. Can you see it? Yeah? It's
Yeah,
these
Doc.
little things. So actually the cytoskeleton is made out of microfilament, intermittent filament, and some microtubules. We'll be speaking about it deeply soon, but just this is the general idea of it. It's just like the skeleton of the cell. Okay?
Got it, Doc.
Okay. It helps transport stuff from point A to point B in the cell. It helps keeping the structure. So yeah, it has some functions. Okay, so this is um, the ubiquitin. Okay, so what is the proteasome? A proteasome is a barrel-like structure, a barrel
Mm-hmm.
like this, and its function, well, he is functionless. He just find the ubiquitin, and when he see it, what he does, he just kills everything inside of it. He doesn't care what is inside of it, he just kill it, the ubiquitin, and whatever is he attached into it. Yes?
Okay,
So
Doc.
okay, he did here, so now he will do it the same idea here. Yes? So this is the ubiquitin proteasome pathway working, correct?
Got it, Doc.
Okay, so you are like, okay, I'm getting it. So he's removing the ubiquitin and the portion of the cytoskeleton, basically, yeah?
Mm-hmm.
Okay, so let's keep doing this really quick. So he's helping in the process of atrophy, correct? Because if you have less cytoskeleton, the cell will be able to become
Short atrophy.
smaller. So that is the process of atrophy. Make sense?
So is this also the process where you use corticosteroids, external steroids, and you have organ atrophy, Doc?
In case, oh yeah, when you use anabolic steroid, why our muscle becomes bigger, you mean?
No, why we have testicular atrophy and stuff like that when you don't use an organ in our body.
Yeah, absolutely. So when you don't use an organ, for example, after a broken leg, you put a cast, and
Mm-hmm.
the cast is there for 2 months, and when you remove the cast, the leg with the cast is much more smaller than the leg without the cast. Yeah.
Yeah,
What
Doc.
what happened? They can ask you. Is the ubiquitin proteasome pathway was working? Okay.
Got it. Got
Okay.
it, Doc.
So they write the proteasome are a barrel-shaped protein complex that degrade damaged or ubiquinate tagged protein. A defect in the and it's helped with the atrophy. There is only one disease related to this. A defect in the ubiquitin proteasome system are implicated in some cases of Parkinson's disease. I try to look in the literature. There is nothing about this as like why it happens. They know it exists. It's a research material, you know.
Got
So
it, Doc.
I tried to look actually because I was interested in it because I was like connecting everything together, but not this one. It does not work because it's just like, yeah, we know there is something about it. There is a few papers about it, but we don't know exactly what it is. That's a good thing. You will not be asked about it. They can ask you about the Parkinson, but not why. So Cytoskeleton element. Can you tell me why the cytoskeleton is important for us?
To maintain the structure of the cell dog and also for the transport and uh,
Yeah,
stuff like that.
even for division of the cell, it's important. Okay, like when this.
Division, okay.
Yeah, so let's imagine one cell wanna become two cells, like in the M phase. Remember mitosis and cytokinesis. So for that, you also need cytoskeleton. Okay.
Okay, doc.
Okay. So it's a network of protein fibers within the cytoplasm that supports cell structure, cell and organelle movement, and cell division. Okay? Basically,
Good.
structure, movement, division, and also protection. Okay?
Got it, doc.
Microfilament. So the microfilament are the smallest. Actually, I don't like just to read them. I want to have something in front of me. Just a second. Okay. So microfilament, these guys help in the muscle contraction and cytokinesis. What is cytokinesis, by the way?
After mitosis, right, doc? In the cell division, cytokinesis takes place.
Okay, good. So they.
Division of the cell, doc. Just basically.
Yep. And what about something called intermittent filament? Oh, so they write here examples are actin and microvilli. Actin help with the contraction. Yeah. Remember the actin myosin fibers?
Yeah, doc.
Yep. So it helps with the contraction. And also we have the microvilli. Intermittent filament, they maintain the cell structure, as in here. And there is so many of them. Some of these you actually have to know, like vimentin and desmin, they are located in the muscle cells. Cytokeratin will be in the epithelial cells, okay?
Okay, doc.
Lamins as well. Glial fibrillary acidic proteins, make a note, these are in the CNS. Same with neurofilaments. It's important to know the location of each of these. Why? Let's say that a patient has an anaplastic tumor, which means a tumor that we don't know the origination of it. Yeah? And
Okay.
you need to find out, well, where it comes from, you know? So you can try to dye desmin. And if it dies for desmin, that means that it's coming from muscle. If you put a dye for cytokeratin and it dies for it, that means it's coming from epithelial cells. Yeah?
Okay, doc.
Make sense?
Yeah. What about lamins, doc?
Lamins are in connective tissues. Connective tissue. I will be explaining something about, actually leave that for later, about fibrinolactin and lamins, but that's a little bit later. Okay?
Okay.
So, because, you know what, let me do it now. I wanted to speak about it in cancer, but let's just do it now. So if we have two epithelial cells here, okay? They can have some form of connection between them. This connection is called cadherin. Is mediated by something called E-cadherin. Okay?
Cadherin, doc?
Cadherin. Let me just show you how it is. E-cadherin. Yes, like this.
Okay, doc.
So
Cadherin.
this E-cadherin connects the two cells together. Like just, oh, nice image. Okay, can you see how it connects cell A with cell B?
Yeah, doc.
Okay. So is that the end of the story? The answer is not. No, it's not the end of the story. There is more into it. So I need to tell you the full story because otherwise it will not make any sense. Let me send you this. Okay. Under the epithelial cells, we always have a basement membrane, yes?
Yes, doc.
What is the basement membrane made out of?
Lipids?
Collagen. Collagen type 4.
Oh, yeah.
Collagen type 4.
4.
And under the collagen type 4 of the basement membrane, there is fibers in the connective tissue. Okay? So these fibers contains two things. Something called fibrinolactin and the other one called lamin. Okay?
Okay.
So why I'm telling you all of this? Well, think about it. If a cancer cells wanna invade and go to the blood supply, which is here, like in the underlayer. It must first of all down-regulate E-cadherin. Yes?
Okay.
Then
To form a gap.
to form a gap. Then it has a basement membrane. So it must produce collagenases, also known as metalloproteases. Okay?
Mm-hmm. Got it, Doc.
And after that, it must bind to the lamin and fibrinolactin. Correct?
Got it. Yeah.
And after that, it must go to the lymph or to the blood. Correct?
Yes, Doc.
Okay, good. Makes sense? It's the whole process. Can you repeat it really, really quick? Just tell me steps of the cancer cells.
Doc, when you said, where those endothelial cells or epithelial cells, Doc?
Which one? The ones I drew there?
The E-cadherin is connecting is the epithelial or endothelial cells?
Epithelial.
Epithelial. Okay.
Yes.
So basically, for a cancer to invade our body, it needs to get through the epithelial cells, and the epithelial cells are connected to each other with the E-cadherin, so that's why it has to break it. And then it needs to invade the basement membrane, which is full of collagen, type 4 basement membrane, and then it needs to go and attach to the fibronectin and lamina, no?
Lamin, yeah.
Lamin, okay. And then it can enter into our body, right?
Yes. So this is how cancer, like that originally was up, can invade the deeper tissues. Yeah?
So this is for melanoma, Doc, you're talking about?
Melanoma is one of the examples, but not only. Even squamous cell carcinoma of the cervix, for example, okay, can be the same. So
okay, Doc.
Okay.
So what do they contain, Doc, for them to destroy this?
Destroy what?
Like E-cadherin, how do they deal with the E-cadherin?
They don't destroy it. They down-regulate it. They send some cytokines to the cells, to the epithelial cells. Well, this is produced by the epithelial cells, the E-cadherin, correct?
Oh.
So
Doc.
They do send cytokines to the epithelial cells to decrease something called the beta-catenin WNT pathway. But anyway, so they just down-regulate it, and that decreases the E-cadherin. Okay?
Okay, Doc.
Good. So, okay, that's lamin. Next one is called microtubules. Microtubules help in the movement and cell division. Movement, yes. Cilia. Why cilia is important? Tell me some functions of the cilia that you know.
To get cilia is for swimming, right, Doc? Movement.
Yeah, also it's important in the mucociliary apparatus. Yeah?
Yes, Doc.
Okay, good. So also we have flagella, which help in the movement, and mitotic spindles, which help in the division of the cell, and axonal trafficking. I mean, if this is the soma of the neuron, and this is the synaptic cleft of the neuron, and you want to move info downward, yes? It moves downward with the help of microtubules, with the help of something called the kinesin. Kinesin, yes?
Got it, Doc.
Okay. So also something called the centriole, which also help with the process of division. Okay? It's an organelle.
Doc, what is the difference between cilia and flagella, Doc?
I would show you. So the cilia, it's a much more smaller structure, and you have so many of it, okay? And it's on one cell. For example, if you take a look at one cell, see how many cilia do you have? So many.
Yeah.
But the flagella is just one. So flagella is mainly for movement, while cilia move the stuff around it. Okay?
Got it, Doc. Yeah.
Okay.
Understood.
Good. It's called there as well. Oh yeah. It's called in Boston.
Oh yeah. We had a very big snowstorm, Doc. I told you, right?
Yeah. You showed me that I saw snow coming from.
I was
the window.
I was shocked. I was like, what is this? I was just pulling up the windows and there was snow inside. So.
Oh my God! Yeah, so much snow. Well, I came to Jerusalem here. We also have snow. We have snow here. So yeah.
Yeah.
So microtubules. Let's speak about microtubules. Wait a
Doc,
second.
did you guys start the group 5, Doc? Group 5
Well,
USMLE group?
I'm actually going to retire the project, man. Since I matched, I don't think it's a good idea to be doing two at one. So
Oh,
basically, man, you and Rosa, my other student, you are my last project.
oh my God, Doc. What about Snigdha, Doc?
Snikta, you know, man, like for step two, you don't need my help a lot. Just you need orientation. That's it. I will be the
Okay,
same like Hayan. I just tell him what to do about it.
okay,
Because
Doc.
like he calls me every week, once a week, once every 2 weeks. He tells me, okay, I finished this. What should I do now? And I give him the task. You know,
Okay.
it's not as difficult as you think. Step two, you need just to have
But
like
I need her to discuss all the incorrects, Doc.
which one?
You don't think you can make time for it, Doc, for her to discuss incorrects?
The
Like
you word,
the
you
U
mean?
will, yeah.
It's possible, but make her collect.
What about your other friend, Doc? Is she doing step 2 classes? The friend you were going to
Oh, you mean
uh,
my ex?
do the step? Yeah, I don't. Oh, there's no it. So how do you say that? Ira or Irie? How do you say it?
My girlfriend now, Irena.
Now, how do you say her name? Ira?
Ira.
Ira. Okay.
Ira.
So yeah. So Maria won't is not teaching step 2 though.
Maria does teach step two, uh, but yeah, I think as I told you previously, I'm trying to retire the project. I don't want to have so much things during my residency, you know? So
Okay.
we checked only like four students were interested and it was not cutting it, you know? So we thought it's just going to be too expensive for people, so it's better not to do it.
Okay, though.
Yeah.
I'm sorry to hear that, though.
Well,
I'm
no.
not tense about Snigdha.
It's okay, man.
But
Like this thing
until
happened.
you start residency, just guide her. Okay?
I
We'll
will.
have 1-2
No,
classes.
man,
Yeah.
not until I start my residency. Even after I start my residency. This is simple stuff. Like the CK preparation, just prepare this, prepare that, read that book, you know? I mean,
Okay.
trust me, man. When I tell her read that book, the next phone call I'm going to get back, it's in 2 weeks at least. If I'm going to get it earlier, I will know that she did not read it.
Okay. Though.
It's a lot of material, but it's a lot of reading. It's nothing like step one. Step one is a lot of
Mhm.
memorization and a lot of like, you need to understand, yeah. But step two, you already understood everything. Now it's just time to memorize the protocols, you know?
Okay. Though.
Yep. Oh, wait a second. Okay, man. Can I call you in 5 minutes?
Okay. Though.
Okay. See you in 5.